In this video, we're going to work on the ALEKS problem called classifying organic reactions. This problem is going to give you 5 different reactions. You're being asked to classify each one of them as either substitution, elimination, or addition. And this problem might look really intimidating at first because these reactions may be totally unfamiliar to you. You might be looking at them thinking, I don't even know what I'm looking at. I can't do this. But I'm going to show you how to do this in a nice and easy way. So for starters, let's talk about elimination reactions. Elimination reactions are ones where we convert a carbon-carbon single bond into a carbon-carbon double bond or triple bond. We're doing that by eliminating some of the atoms from the molecule, so that's where the name comes from. But basically what you're looking for is a single bond being converted into a double bond or a triple bond. And that you might think, oh, that's going to be really hard for me to find, but it's not. When you're looking at these reactions, I want you to look at the products of these reactions and look for double bonds or triple bonds. See if you can find any. So like in this first reaction right here, look for a double bond. There it is right there. Now that doesn't immediately mean that this is an elimination reaction. An elimination reaction is one specifically where a single bond is turned into a double bond. So once we have found the double bond, we need to look back and figure out, was that double bond always there or was it created? This double bond was created in this reaction. The carbon-carbon single bond was turned into a double bond, and that means that this is an elimination reaction. It's an example of elimination. Let's look at this one right here. Right now we're just looking for elimination. This reaction right here, we're looking for double or triple bonds in our products. There are no double or triple bonds in these products, which means this is not an elimination reaction. Let's take a look at this one. We're looking again for double bonds or triple bonds. We've got double bonds all over the place in this molecule, but that doesn't necessarily mean that this is an elimination reaction. Elimination is when we convert a single into a double. Was this double bond always there? Yes, it was. What about this one? Always there. So in this molecule, we're not creating double bonds. They were always there the whole entire time. This is not an elimination reaction. This molecule, again, let's think about what we're doing. We're looking at the products and we're trying to decide if there are any double or triple bonds. This has no double or triple bonds in the products, therefore it is not elimination. And for the last one, again, no double or triple bonds. That means it's not elimination. Again, elimination creates double or triple bonds. Okay, so let's look at the next type of reaction that we have, an addition. Addition reactions are ones that do the opposite of elimination. So they will take a carbon-carbon double bond or a carbon-carbon triple bond and turn that into a single bond. So how are we going to find addition reactions? In that case, we're basically taking the opposite approach. So we're going to look at the reactants and we'll look for double or triple bonds. This reaction starts with double or triple bonds and turns them into singles. This one over here, there are no double or triple bonds. So that means that this cannot be an addition reaction. This molecule has double bonds all over the place. Do they get turned into single bonds? We've already talked about this. No, they don't. These are double bonds that are unchanged over the course of this reaction. So this reaction is also not addition. Here we have a couple of double bonds. And if we look at the products, those double bonds are being turned into single bonds, which means that this is an example of an addition reaction. And we've got one more down here, a double bond that is being turned into a single bond. So this is an addition reaction. This reaction works by adding stuff to the double bond. In this case, we can see we added a chlorine to the double bond. Now, there's one more type of reaction, which is substitution. And just by process of elimination, if a reaction is not elimination and it's not addition, then it has to be substitution. But if that's not, that's not a good definition for substitution. A substitution reaction is one where we replace an atom or sometimes multiple atoms with new atoms or just one. So it's where we're replacing an atom with new atoms. And these can be a little bit harder to spot. So I definitely recommend that you start by looking for the elimination and addition reactions. Those are the easiest ones to see. And then once you have decided that a reaction must be substitution just by process of elimination, then that makes it a little bit easier for us to see what's going on in terms of the substitution. So in this reaction, I've highlighted the substitution. We are replacing this 2-carbon chain with a hydrogen. That's a substitution reaction. This is another reaction that we decided was substitution. This one's a little bit harder to visualize because the hydrogen is not showing, as is customary on a line structure. In this reaction, the hydrogen is being substituted for a bromine, so that makes it a substitution.